Hello guys, welcome back to my YouTube channel. Let's brush up what we have learned so far. So we have started differential vector calculus. In there are mainly three operators: gradient, divergence, and curl. We have started gradient. So the symbol is this triangle shaped symbol. This is also called del, nebula, gradient. People also prefer writing this grad. And we have discussed this example, and I have said this trick so that any problem in the terms of position vector gets easier. So let's quickly brush up that. So when r is equal to position vector r is equal to xi cap plus yj cap plus zk cap, we can also write r as summation of xi cap, so that when we expand that we get xi cap plus yj cap plus zk cap. Okay, and the mod of the absolute value of that vector is given by square root x square plus y square plus z square. Now when we partially differentiate it with respect to x, we get I cap. So when we partially differentiate the mod value of r, we get x by r. So these are two important values we have to remember. Similarly, we solve the problems based on that. If we apply the conventional formula for this problem, it will take forever to solve. By this trick we solved in a couple of steps. So let's continue with the problems. We do a lot of problems in this course. So let's take another example. Take example, find gradient of the function phi is equal to e raised to, I'll write exponential raised to x squared plus y squared plus z square whole raised to 3 by 2. So I'll recommend it to you to pause the video and try for yourself, and later match the solution. Okay, let's solve this question. Phi is equal to e raised to x square plus y square plus z square whole raised to 3 by 2. We know that r square is equal to x square plus y square plus z square. So raising the power 3 by 2 on both sides, we get r raised to 3 by 2 into 3 by 2 is equal to x square plus y square plus z square whole raised to 3 by 2. So this is in fact phi. So the function is in the form phi, so let it be that way. We get r cube is equal to x square plus y square plus z square whole raised to 3 by 2. So the given function will be in the form phi is equal to e raised to r cube. So now apply that trick, that formula. Grad phi is equal to summation of I cap into del by del x of phi. We get summation I cap into del by del x of e raised to r cube. So when we differentiate it, we get e raised to, we should apply the chain rule here. So we get I cap into differentiation of the exponential function is the exponential function. Again we have to differentiate this term separately, so it will become 3 into r square. Again we have to differentiate this term, so we get del r by del x. I'll again simplify it now. Del phi is equal to I cap into e raised to r cube into 3 into r square into del r by del x is x by r. Yesterday we have written. So by solving this we get r and r gets cancelled, 3 and all these terms come outside, so we write 3 e raised to r cube into r into summation of I cap x. So we get del phi is equal to 3 into r into e raised to r cube into r cap. So this is the final answer. Take a look at this solution. If you have any doubt, please feel free to comment. I'll try to answer your doubts. Okay, moving on to next question. Find gradient of the function phi is equal to log to the base er, or sometimes we call it ln r. So just make it log to the base er. So what we get, del phi is equal to s, applying the same formula, I cap into del by del x of function, that is log r. We get I cap into differentiation of log is 1 by that function, r, again del r by del x. It implies del phi is equal to I cap into 1 by r into x by r. We get 1 by r square into I cap into x. So we get del phi is equal to 1 by r square into r vector. Okay, moving on to the next question. Question is, find a dot del into r vector if a is a constant vector. So how do you solve it? Let's expand it. Take a is equal to a1 I cap plus a2 j cap plus a3 k cap. So when we do that, we get a dot del, remember this is just now it's in operator form. We get a1 I cap plus a2 j cap plus a3 k cap dot now writing this del term I cap into d by dx plus j cap into del by del y plus k cap into del by del z. Solving this we get a dot del is equal to a1, remember it has to be operator, so I'm writing like this, plus a2 into del by del y plus a3 del by del z. Now in the question we have asked this, so we'll write a1 into del by del x plus a2 del by del y plus a3 del by del z whole multiplied by whole operating on r. If we simplify it we get, remember this is a linear operator, so we get a1 del r by del r vector by del x plus a2 into del r vector by del y plus a3 into del r vector by del z. So we get a dot r is a dot del into r is equal to, we'll have to simplify. Remember I have said this corresponds to I cap, this corresponds to j cap, this corresponds to k cap. Remember we have discussed that in a previous class, so I'll write it directly, a1 into I cap plus a2 into j cap plus a3 into k cap. This is in fact the a vector, so the answer is A. I'll zoom out, just check out the solution. Now if you are wondering how we wrote this as I cap, j cap and k cap, I'll also explain that. See, consider r is equal to xi cap plus yj cap plus zk cap. Partially differentiate with respect to x, meaning only treat x as variable and remaining terms as constants. So we get this as I cap plus 0 plus 0 del r by del y is treat y as variable and x and z as constants. So we get j cap and del r by del z is equal to k cap. So I substituted these values in the above equation. Okay, clear? Now let's move on to the next problem. This is a very interesting problem yet. So problem is find psi of r when del psi is equal to r vector by r raised to 5. So this is an important and interesting problem. So what should we do now? I'll suggest you to pause the video first and then try and then match the answer. So I'll solve it now. Take psi of r is equal to some constant into raised to any arbitrary power n. We can also add the terms like br raised to minus n minus 1. So it doesn't make any sense if we do that, so I'll just stick on to c into r raised to n. Now if we take the gradient of this function, we get del phi is equal to n into c into r raised to n minus 1 into I cap into del r by del x is equal to n c r raised to n minus 1 to I cap into x by r. We get n c r raised to n minus 2 into r cap. So del psi is this much. So we equate this only power term with this term. What we get, r by r raised to phi is equal to n c r into r raised to n minus 2 into r. Remember, we are not done with the problem yet. After equating the power, we still have to simplify it. So what we get, r raised to minus phi is equal to r raised to n by 2. We get n by n minus 2 is equal to minus phi. It implies that n is equal to minus 3. So we get psi is equal to c by r cube. Remember, we are not done with the problem yet. Sorry, I stand correct. This is not grad of phi. This is simply phi is equal to c into r raised to minus 3. Now take the grad is equal to c comes outside, I cap into del by del x of r raised to minus 3. It implies c into I cap into minus 3 r raised to minus 4 into x by r is equal to c into I cap into minus 3 into r raised to minus 5 into x. After simplifying, we get L psi is equal to c into minus 3c by r raised to 5 into r. So in question we have asked only this much, so we have to repair this equation now. It implies that 1 by minus 1 by 3c into del phi is equal to r by r raised to 5. So we have to take this term inside this term. It doesn't make any difference. Then we have del of minus 1 by 3c phi is equal to r by r raised to 5. So we have the final answer. Now put this value in here. We get del 1 by 3 into c into c r raised to minus cube is equal to r by r raised to 5. C gets cancelled, so we have phi is equal to minus 1 by 3 r cube. So this was a very interesting question. I suggest you guys to practice these questions and many more questions from any reference book for that matter. And I'd like to request you to subscribe to my channel, like, share, comment, and feel free to ask any doubts. Thank you.